All right then, good afternoon, everyone. Welcome to the STEM Expert webinar. I'm Samuel.
Um, I'm Harry.
I'm Jalen.
And I'm Sarah.
We'd all like to thank you for coming to our very first expert webinar of the season. Before we begin, we'd like to share some info about our robotics team. So Wolf Corp is an FCC robotics team based in Walnut, California at Walnut High School. We participate in the First Tech Challenge, a robotics tournament hosted by an international nonprofit organization called FIRST. FIRST aims to inspire youth into STEM through robotics and various levels of competition. This is our 5th year in FTC, and we've maintained a high-ranking position throughout many competitions in the Los Angeles area. In addition, for the past 2 years, we've also qualified for World Festival Contenders, which takes place each year in Houston, Texas.
Just a brief reminder that we will be hosting a Q&A session after all our experts present. So if you have any questions for any of the presenters today, please note it down to ask later. Up first is Mr. Morris, a data product analyst expert from Capital Group.
Hi, everyone. Can you hear me well?
Yep.
Okay, good. Yeah, hi, my name is Brandon Morris. I'm a data product analyst at Capital Group. In this presentation, I'm just going to give a journey through my world of data. Next slide, please. I'm going to break this into 3 different parts. One's going to be discovering the world of data, which is basically the intro. The second is going to be the actual journey. And the last part's going to be the decision. Next slide. So I discovered the world of data. I was introduced to coding actually in middle school. I was using Tumblr, and you can see at the bottom, it's a screenshot of my Tumblr page. It's really cool, I guess you guys can say. On the left side, you see like the HTML code, and I was copying like stuff from Stack Overflow, and like really trying to make it like really cool and competing with my friends and whatnot. And I had no idea what I was doing, but I was literally like coding and actually like learning different things to really prepare myself for what I'll be doing here in the future. And then also with Excel, I was using Excel a lot, like the formulas for projects and reports in high school. And then also stock market analysis. I mean, I had to create some formulas within Excel to do things like that, just to learn how to evaluate companies. So all of that was really just preparing me for how I would probably be, introduced to that world of coding for the future. I guess for my family, and that he's a computer engineer and my mom's a science teacher. So I never really got a break from school at home. I would just come home and school would continue. My dad would like take me to buy computer parts from warehouses. So like he would build computers from scratch. And, for me, I guess I was always introduced to that world of computers and coding. And it was just really something that to myself, it was just normal, right? And I had imposter syndrome because I thought it was just so much. Like I would see my dad building all these things and my mom talking about, her classes and stuff. And I'd be like, I don't know if I can do this. So I was introduced to all of this. I had all the necessary components to be, someone that can enter that world of data. And in the next slide, please, I'll talk more. In the next slide here, actually for college, I started as an econ and computer science double major. And what's crazy is I think my first few classes, I couldn't really perform well for computer science. Like I had issues writing print statements, which is like one of the first things you learn. And I had to drop that major, the computer science major, and I switched it for a minor in data analysis, which is basically just a few less classes. But I only made that decision after doing some work and internships. One internship that I worked on is a accounting internship, but I did some coding during that accounting internship, and that reestablished my love of data, my love of learning coding. And because of that, I made that decision to switch the computer science major to a data science minor. I also joined some pre-professional development groups and programs that connected me with some companies here in the LA area. One of them on the bottom left of the screen, that's Aries. It's in Avenue of the Stars area. And at Aries, I also did some coding work for them as well. This picture in the center, that's just describing a little bit more about myself. I was also a student athlete. And it also, allowed me just, I guess, to have that kind of mentality of just like persevering through those tough times of like trying to balance that workload. But yeah, I mean, I think my time working those internships really pushed me forward to have that, what I need now for my next slide. Yeah, it pushed me forward to start at my current company, which is Capital Group. I started here 2 years ago in September 2019. After doing those internships, they gave me what I need to like think about, okay, I'm going to be working in compliance, but I need to find ways where I can apply those skills that I've learned in the past, right? Like from being introduced to Tumblr in middle school and working all the way up now, I was able to use some of those things I learned in school to be able to write automation scripts. On the bottom left, you see there's something called Alteryx, which is an automation platform, automation software that allows me to do things like filtering, sort, summarize, like all those different types of things to like a table, basically. So I recognized some opportunities while working as a compliance analyst to be able to use those skills. And then after doing that compliance work for about a year, I switched onto a data team where now I build like reports for portfolio managers, quant analysts, and results analysts. And I completed a data science certification just to make that move into the data science field. So for the next few months, I'm just practicing and training now to make that move. So the top right picture, you see some Python code. So like import statements, just like the top of a model that I've been working on. So all of the things that I've really, like I said, started off with, I had no idea I was really coding. I had no idea like I was being introduced to that world. And I slowly started to make that decision into switching into data. And I think a lot of us have that imposter syndrome. Oh, sorry, next slide. A lot of us have that imposter syndrome where we don't think you can make it into that world. Like it's difficult. Like, I don't know if you can do this. It's hard. So I had these three things here. One is not just the knowledge of the tool, but knowing when to use each tool. There's so many different ways to write scripts nowadays. But if you don't know how to, like, when exactly to use that tool, I mean, you're just wasting your time. In any career in the world of data, you're not going to focus on the numbers, but also on how those insights are communicated. There's a lot of things I do for my day-to-day, but I have to be able to tell a story with data. Like when I'm giving presentations, I'm talking about a script that I wrote or a problem that I've solved. I have to be able to communicate exactly what's going on so that someone else can understand how to build it and also how to like fix it and whatnot, like just the maintenance of that tool. And then lastly, no one knows everything at first. Google's free. I mean, a lot of things are online. You don't need to actually just know exactly how to do something. Like Stack Overflow and other types of services. They give me ideas of how to write a certain script or how to maybe do something more efficiently. Like you don't need to reinvent the wheel to be able to fix something. But that is all. Thank you, guys.
Thank you, Mr. Morris, for sharing about your path and career. Your journey as a data product analyst is very inspiring. The following presenter is Mr. Wu, an engineer from Warner Bros.
Hello, can you hear me? Okay. Hi, good afternoon. My name is Mr. Danny Wu. I'm a senior engineer at Warner Brothers. Next slide. I started working there in 1993. My college background is I was at UC Irvine for applied physics. I went in particularly going in there because of family, family lines where we were all physicists or either physicists or doctors. I was the first in my family to, in my entire family to move away from that line and go into the computer side of business. And basically it was, the reason why is because I was always interested in games and like the rest of the games is the entryway of computers. And the other thing I was interested was in film, in movies and films and TV. So I decided to switch over from applied physics after 2.5 years of that, of trauma, and then going in from applied physics science into computer science, computer information systems. I researched that, and it was between information systems and going with computer science, and I decided I wanted to go into the, like Mr. Morris, I wanted to go into the data side, but with emphasis in telecom network and database design. And then during that time, I was also like hearing a lot of word that, hey, if you minor in accounting information systems, you make big bucks and there's a lot of jobs out there during that time in the 90s. That was true, but then, by the time I got out of school, I was burnt out of numbers and I wanted to get out of that. And I started working in internship, and the internships, I was inside the database design and the network infrastructure teams. And that's where, you get additional foundations to supplement what you had learned in college. So the key thing for my thing is that you have to have a really good foundation, and that foundation is built through college, and that foundation is going to teach you the logic, the troubleshooting, it's just a wealth of information. With these days, back then and now, you have Google and you have all the information in the network, in the internet now. But back in the day, there was none of that. And basically, it was a lot of books and a lot of calling out your networks of friends and the people that you work with in the workplace. You meet up people in the conferences and the shows, and joining in associations with the the people that you are in that field with. Next slide. So when I first got out, I actually started working in the field that I really wanted to work in, which is in games. And I worked there for about 5 years before I got into films. So from Disney, I worked at Disney Interactive for about 5 years, and it was in the infancy. And we were working on pretty much good amount of games. I've learned concept of programming and design, and from there I was able to meet with several people who actually moved on to Warner Bros. And when I went to, they were able to get me in. I got in through Warner Bros. I interviewed on my own, and my first few films that I worked from 1993 to 1999, I was given a few of them, and I worked all the way through, like shows like Unforgiven, Free Willy, and Bodyguard and Demolition Man. I don't know if many people know about these. These are pretty old films now. Next slide. So 1999 was like the breakout year for me, because basically I proved my worth at the film industry, and I started working on every single film from then on. So I moved on from just a regular engineer to a senior engineer, and basically was tasked to modernize the film workspace and try to digitize them, because previously everything was done on film. And as you know, that now a lot of the directors now we're shooting in digital now. There's still directors that will still use the film side, but it's still challenging that we have to convert the film to digital. Next slide. So from 2012, I was tasked with another task, which was moving into the internet age, where we're talking about streaming, and our company has decided to start up small, and we started doing OTT content to streaming to the consumer. So that was a new added task for us, and so basically we miniaturized what we were doing in the film side, and created a digital workflow in the internet, and we were able to do so and do it with a small amount of money, so that we can prove that we can downsize the actual film and TV portion. And so with that project, we were able to then start to put in roll in effect all the digital, all the films, and we started to roll them out into to digitized format. So in 2015, I was able to then start moving that digital workflow into a cloud, because prior to that, everything was on server basis inside a facility, and then it was transferring from one facility to another facility. Now, what we started doing was we started moving the infrastructure into the cloud, because then we can centralize the location, and then the data can be shared amongst different vendors around the world. We became a global company around 2014, and data is now across the world right now. And we were shooting in one location with 3 different teams in different locations, and we had to get the data in a central location for people to edit. So that came about in 2015, and in 2018, we were just starting the virtual productions. And the virtual production, I'm just trying to make it very fast because there's a lot to deal with, but virtualized systems. Basically, in the old days, we used to use green screens, and now we're replacing them with LED walls. These are giant walls, like 40, 50 feet tall and wide. And basically, it acts like your green screen. But the advantage of that is that we can make set motion onto it. And then the actors can actually feel that they're inside the workspace instead of just acting in front of a green screen where people just kind of don't have a good time of acting. So now they can see and feel the world moving. The camera's moving along with the actor and the screen. So you almost cannot see the difference between a green screen and the LED walls. With the LED walls came with more and more cloud technology that we have to send the information quicker and allow us to have we have multiple vendors working on different corners of the world, and they have to just get access to the data quicker. And then this is allowing the production to go a lot quicker. Let me see. The pros and cons of working at Warner Bros. Or any of the studios. It's a constant learning of good things. Redesigning old ways. We're always tasked with learning new things, applying the new things, or we're on a cutting edge of every new tech. We have to change quickly because the budget constraints are getting tighter and tighter. The days of like spending like 200 million, 300 million a movie is getting smaller and smaller, because now we have to compete with tons of content that are being produced by Netflix and Amazon. And so these guys are tech oriented. And so they're using the tech ways to come into to the studio, the old school studio film ways. And so they have an advantage of that, but we are moving in a fast environment to keep up with them. The cons is constant long hours, because we work 24/7. Basically, our team does. Our team is based in, we have a team of 5 here that I manage, and I have a team of 5 in the UK, and I have a team of 3 in the Philippines. And we're constantly, trying to make our on-site, talking with vendors and talking with the engineers that we hire out to be there on the field, because we've been working virtually or remotely since 2012, and the hours is just around the clock, because you just like I work from 6 a.m. to 11 p.m. in the evening, because I catch the UK people because I need to talk with them, and I also need to talk to the Australian people. Next slide. I talked about I didn't want to be an engineer, and because I wanted to, do something different, and that was my interest was always in games and movies, and that's why I didn't want to be a doctor or a regular physicist. but I think what I've done in my life it's been pretty fruitful and challenging for me, and that's my personality. And if you have that similar personality, then it drives you to this type of field. What you need to be able to have is the ability to focus and tune out distractions, and you need to be able to multitask and prioritize tasks on hand, because they're in the real world out there. They're like, not only are you given one task, but you're given simple of multiple projects going on at the same time while you have your normal day-to-day job. So you have to kind of be able to prioritize that. And then when you go to college, you're going to see that you're going to have multiple classes, just like right now in high school or in regular school, you have classes, but in college and then when you get into the real world, you'll start seeing that these tasks are like pretty long and winded, and you just need to get them done. And there's no, oh, I'm going to turn in late because there's no late. Communication is a key. You need to learn to be able to talk to clients and staff effectively, and that you will learn with college and going to the many work groups that you start learning. And then when you start going to the workplace, you will have that experience because you will be working with the staff and the team. And again, I'm going back to just making sure that the key is getting the good foundation that you can get in college, and then the key, really big key is get the internship like Mr. Mars had in the previous conversation. Internship is key. You start to network with people, and then that's how you move on. Thanks.
Thank you for taking the time out of your day to share your amazing project with us, Mr. Lee.
Next up, we have Mr. Zhang, an IT specialist that works for Cybersecurity Governance and Operations Branch.
Let me share my screen. Can you guys see my screen?
Yes.
All right, cool. By the way, I think Connie, this big blue marble is beautiful, the picture. Thank you for sharing with us.
Thank you.
All right. Yep. A day in the life of enterprise architect, right? My name is Kanlu. I work for Los Angeles County. I'm the enterprise architect for cyber governance and operations branch, right? So in these kind of next couple of minutes, I want to kind of try to answer two questions, right? One is to say, hey, what's enterprise architect? The second is what we normally do at work, right? So let's try to see if we can get some idea. Enterprise architect, I think maybe I block my screen. Okay, so enterprise architect of our LA County is to lead the team to kind of design the architecture of IT infrastructure, right? And also to implement, to maintain them. Right? So for LA County, I think we provide so many, about 500 more critical public services, right? Websites to residents in LA County. A very good example is that if you want to borrow a book, or maybe to kind of reserve a conference room in library or something, then you normally will go to library website to reserve that. Right? Also during this pandemic, when you want to get some vaccination information, you most likely will go to our health service department or public health service department to get that information. Right? All these kind of critical website living inside our infrastructure. So as enterprise architect, my job, my team's job is to support this architect to make sure this website, this web application to kind of up and running all the time. Right? And not only that, we also need to secure them, right? So many bad guys kind of in the internet try to get the data from us. Right? So as you can see, I think right now, I think we have about 3,500, maybe more virtual server keep increasing in our data center, also in the public cloud, right? We have a database from small to big, from gigabyte to a terabyte, right? So all these things that we need to kind of handle to support them. All right, let me see. Right, so I didn't, it's still not answer, hey, what's an enterprise architect, right? So I want to kind of share with you some very high level kind of visualization about our infrastructure to show you that, hey, what we normally handling, right? So as you can see, underneath the bottom layer is represent our data network. Right? In the middle, we have data centers, and then we have enterprise network, the green one, which connecting about thousands of remote office, go back to a centralized data center. We also, on the right side, we have a multi-cloud. Basically, we can move our server, virtual server from our data center to AWS, to Google, to Azure, right? On the top is represent internet, right? So you might asking that, hey, what does that mean to us? Continue to our example is that if you want to access kind of library, right? I want to kind of borrow a book, maybe reserve a conference room. What you do normally, let's say, hey, you are in the up here, right? Represent you. You're internet visitors. You're sitting at home. Open the browser. You will type in https://lacountylibrary.org in your browser, and you hit the enter. When you hit the enter, you will show the web page of our lacounty.org, library.org page, right? So, but behind the scene, where is lacountylibrary.org resides on sitting area? It actually sitting in our data center, which is represented here, right? So when you get your web page, actually you're going out from internet, going to our data center to fetch the data, and then go back to showing on your browser. Right? So this kind of demonstrate that, hey, the data flow from your browser to our web server, which is library.org, right? And go back to you, right? Try to give another example is that what happened, our county employee sitting in our county office, how do they go to get the data to access, for example, google.com, right? They want to get some information. Where will they go? With this infrastructure in mind, the data flow will be like this. From the remote office, they will go from remote office to data center, and then it will go to our internet pipe and go out the internet to reach Google, right? And to get the data. Right? So this kind of show you that as an enterprise architect, you need to know your environment. You need to know your infrastructure, right? Otherwise, I think when issue happen, you will not be able to troubleshoot, to find the issue. Or that way you cannot help your customer, which is our residents, right? So that's kind of first question to see, right? The second one would be, well, normally what do you guys do at work? I give you a very quick example, which is still fresh and hot, right? This is one of the tasks we do normally at work, right? The issue is happened about 2 weeks ago, right? Around maybe a week ago, about on August 16th, our kind of agents, right? Which is kind of helping our customer to take the phone call to provide information. They call in, right? They say, hey, when I talk to customer, our phone call got dropped, right? So that's critical issue. Imagine that you're talking to our health service representative or something, not the doctor, right? Something like health service provide information. The phone was dropped. Then the service is really bad. Then we need to solve this issue as soon as possible. So we follow this kind of the blue line showing the bottom to this kind of escalation path to solve this issue. Right? This happened really fast. Our help desk get the report. They will collect some information. They will create ticket. They will escalate to tier 1 engineer. When tier 1 engineer, they will do some troubleshooting at the layer. If they're still not able to fix it, they will normally escalate to tier 2 engineer. Tier 2 engineer normally are subject matter expert, right? They're really good in certain area, right? They will look in deeper into the area to find the root cause, right? If they're still not able to solve the issue, they will escalate to me, right? And then to the enterprise architect level, right? So when we jump in, the first thing we need to know, we do normally is to see, hey, where is the issue happen? We need to find out the pain point, right? So after troubleshooting, with this high picture and the overall picture in mind, we troubleshoot. We found the issue is that for this particular issue, it happened in as you can see in the red X, right, which is represent our data pipe in here. Something happened in here, so which prevent our net user, which is our agents, when they talk to this call center in AWS through internet. So I think, of course, they will not have a good user experience, right? Keep dropping on and off, right? Now we found the issue. What would be the solutions? We cannot let this happen. Right now, maybe it's working fine. How about in the future? We need to prevent this to kind of provide quality service to our customers, right? So now then we need to log in, right? Do we have other options? Yeah, yes, we do. We do have a light blue pipe, see here, in our network, which is kind of handling other service like virtual private cloud, right? Connect to AWS, right? But can we utilize this pipe to build a new connection between us and AWS Connect, right? So after discuss with AWS architect, right, we have a kind of team-to-team communications. We say yes. Then we work out the solutions to build out this proper line. After we build out this proper line, as you can see, our agency, when they talk to the call center, they're no longer going through internet. Instead, they're going to this new pipe. We got the two benefits right away, right? First, we're not going through internet because they would be more secure. Reason why? Because internet is always treated as a very unsafe environment, right? So many bad guys, hackers living in the area, watching your communication, try to get your data. Right? So if you can avoid this internet, they would be much more secure. Right? So that's why when you go through the purple line, and that's kind of our direct connection to AWS Connect, it's much more secure. Right? The second benefit is that after we build up these purple line connections, we have our private link, also it's direct connect. Right? So it's kind of much better performance, right? With this kind of implementation, then I think problem solved. Not only solving the problem, but also we have a better design, better infrastructure. So our customer is happy. They have a better services, right? So this is one of the kind of many tasks normally enterprise architect would do. I just want to use this opportunity to share this case so you will know something about enterprise architect. I think that's all I have. And I think I kind of put my contact here. Feel free to reach out and if any questions, right? Thank you. That's all I have.
Thank you for sharing a day in the life of an enterprise architect, Mr. Zhang. It's amazing how complex yet simple the problems and solutions can be. Finally, we have Mr. Cho, an ASIC physical design engineer.
Okay, can I share?
Yes, hold on. There you go.
Okay. Sorry, just a bit slow. Okay. Good morning, everyone. My name is Wei Chun Cho. I'm going to give you a quick idea about so-called IC design. IC means, I think everybody knows, integrated circuit. And our daily life needs IC. And actually, the history of IC is not that long. So I'm going to give you a quick milestone all these years. And actually, it's a solution of a software and hardware together. And I'm going to talk about the most core technologies, which is IC design, and conclusion to take away, and a little bit about myself. If you are looking back, actually, you will be amazed that the first computer from and until now is only 60 years away, 60 years ago. So in that 80 years ago. In these 80 years, a lot of things happened. Then the human history actually have a very big technology jump. And so 1943 we have our first computer, and then 1973 we have our first cell phone, and the first PC is come out in 1982. And even the internet history is only starting from 1989, only for 30 years ago. So within this short amount of period, we have a big, the human history has a big technology jump. Also, 2000 year, we have terrible .com bubble, and too many .com company, and I've been through that time, but immediately we recover, and immediately we have a third generation wireless deploy, 3G, 4G, and right now 5G. So and you can everybody has iPhone right now. It's actually released, first iPhone released 2008, and the iPad released 2012. Currently, the most popular technology is human focusing on the AI, artificial intelligence, virtual reality, autopilot, machine learning, and including robotics. So I think all this application is here around the so-called IC. IC is the most important core technology to implement all this. And there is a very famous law called Moore's Law. Moore's Law, Gordon Moore, who is the founder of Intel, he said this law that IC design doubles the transistor count every 2 years. That's why estimate in very long time ago. And right now, Moore's law actually really follows and got followed. And also, why do we need increase our IC count? Because our application is more complicated. We need faster speed. We need a smaller element to be able to fit more functionalities within the chip. And we also need a lower power, otherwise your cell phone will burn. So all this technology actually implemented by IC, and you can see from the right hand side, we have this technology node. You know, COVID-19 virus is how big is the size of COVID-19 virus? It's about 90 nanometer. Right now, our smallest transistor element channel length is 5 nanometer only, is in production right now by TSMC. So you can imagine the technology is actually very, very advanced, robust. We keep shrinking our technology, and then all the techniques is more complicated than before. So next, then I want to give you some idea about actually it's all about application. What do we want to do? And application is actually software and hardware. And this is our daily application. For example, if you open up your computer, if you try to text in your cell phone, it's all just the application. And application is mainly referring to a software. And software give you it actually is a collection of commands written in the computer languages, and all these commands do what you want. But it's not just the software itself. You have to software is actually running on a platform. The platform is called hardware. Hardware is mainly is an implementation of some very core basic computing operation. You made that as a hardware, so the speed will be very fast, and it can be shared by many applications or even specific application. So, for example, CPU. CPU in your laptop is just a group of very basic core instructions and made as a hardware to be executed for you. GPU is a graphic CPU, and ASIC meaning a specific application specific IC, and also RAM memory. Sorry for that. All are make that a hardware system, and then your software running on this hardware, and then you get your application. And all this application that IC design is a core technology, as I mentioned. And a very interesting thing I wanted to mention is software actually running on hardware, right? But hardware right now, hardware is so complicated, you are not able to make by human. So hardware actually designed by software, and this is a very particular knowledge and field. We call it computer-aided design. This is in the college we have a department for that, and in industry we call EDA, electronic design automation. That's remember this term. This is a very important field that in this industry, we made software to create hardware. Okay, sorry. Then on the right hand side, there's a lot of a field. As you can see, if you want to choose computer science, mathematics is more related to the software, and double E and computer engineering is more related to the hardware. Especially computer engineering is a category of a CAD or EDA. All right, next one. Okay, sorry. Then just to give you a quick idea about IC design. So what's the IC? IC integrated circuit, right? We are using IC every day, every minute. Right now, I'm talking with you. I'm using a lot of IC right now. IC is a design. Right now, I'm talking about how the total solution is including synthesis, including precision, including testing. It's nothing just but implement your specification to become a chip. Then it involves so many, as I listed here, is a lot of detailed steps. Each step is a very deep field that it can be a master or PhD thesis for each field. And we are creating. I'm in the industry IC design, and I'm going through this step every day. And so I can quickly give you an idea that we are starting with the specification. It's just a language, just like you're writing your program. And then this language is called hardware description language. And then there's a specific compiler gate. N gate, O gate, all that is a very basic gate. Then we're going to for planning to make your to decide your size of your chip, and then you place all these element gates like N gate, O gate, and then you create your synchronization. Synchronization is very important in all the design that you want to transition your state. So this is called clock synthesis. Then you connect them all together. It's called routing, and then rest step to close up. So I think those are just give you a very basic idea, quick idea. But each step is a very complicated step. You will spend a lot of effort to implement each one. The most important thing is the so-called QOR. If you want to just create a chip, it's actually simple enough. But we want to make it the high speed. We want to make it the smaller area. We want to make it low power. That's the hard part. So we want to achieve this one. So that's why people make that chip involving. And from 100 nanometer right now is get down to the 5 nanometer, and all the technology get around is more complicated before. So that's the daily life we're using. And if you are interested in this field, you can Google it, and you're able to get a lot of information. And each step is actually very deep technology to create your daily life. Just right now, I don't have time. I just give you a very quick idea. So let's talk about the conclusion. So computer and communication, network communication is actually improve our daily life, and that involve the computer science, double E, computer engineering, physics, mathematics field. And most important thing is IC design is a core technology for all this application. About myself, I got a PhD in 1999 in University of Southern California in the degree of double E, and I have 12 years of experience for so-called physical design engineering. That engineer, that's the design. That's the title for designing a chip. And I also have this 10-year manager experience for EDA system. So that's about me. And yeah, but okay. So thank you everyone, and I give a quick link if you want to read all this information, and those are links for you. And actually, you can search for Google. There's a lot more there. Thank you very much. Thank you.
Thank you for your presentation, Mr. Cho. It was very interesting learning about the many different programs you use to design the electronic parts.